Okay, another equation was
Oh, it was three
this one.
halves.
I'm sorry?
It was three.
It's 3.
Three halves, not 5 halves.
We could do it for 5 halves, it'd be about the same. I mean, different numbers. Okay, 3 halves, thank you. Okay? So how do we solve it? Well, x minus 4 is tied up in that 3 halves power, right? We're going to want to get the first power of that so we can get a hold of x, right? So we'll need a 2/3 power to get to x. You might not totally understand what that means until I do it, but it's very similar to what we just did with the log. We had an x tied up in the log, it was an x squared, but that's okay. Okay? We had to convert that to exponential form. Okay? Well, this isn't exactly a conversion, but we do need to be able to get to that x. So what we do is, well, we need x minus 4 to the 3 halves equal to something before we can take the 3 halves power both sides. Because if we try the 3 halves power of the left-hand side, we can't separate that, or the 2/3 power, we can't separate that into the 2/3 power of this minus the 2/3 power of this. 2/3 power is not a linear operation. Okay? So what we have to say is, well, let's okay. If we get it into this form, okay? We rearrange it, we take the 2/3 power. So we have x minus 4 to the 3 halves raised to the 2/3 equals 5 raised to the 2/3. That's just something you can punch into your calculator. And this comes out just x minus 4. Now, just to be sure we understand why that comes out x minus 4, by the laws of exponents, a power of a power, you multiply the powers. So we have 3 halves times 2/3. That's why we chose the 2/3 power, right? So when we raise this to the 2/3 power, we're going to end up with just x minus 4 to the first power, which is just x minus 4, right?
Yes.
And that's equal, in every case, to 5 raised to the 2/3. Well now, if x minus 4 equals 5 to the 2/3, can you tell me what x is?
Yeah, first I had to figure out what 2/3 is.
Well, if x minus 4 equals something, x equals 4 plus that something, right? And formally, we add the 4 to both sides. Then we get x equals 4 plus 5 to the 2/3. That's an exact solution. Okay? Now, that's approximately equal to, I'd say, 6.2 maybe. That's a quick off-the-fly ballpark thing that might actually be close. It's not, it's 7.
You're right, it's 6.62.
6.62? That's ridiculous.
That's ridiculous.
That's ridiculous.
Oh, wait a minute.
That's not even right.
No, it's not even close. I've been ignorant. 5 squared, I won't even tell you what I did. Okay, if 5 squared was 10, I might have been close. Okay, 5 squared is 25, and the 1/3 power of 25 is about 3. But it's a little less than 3. So it's about 6.8 would be my estimate.
Am
Yeah,
I?
it was like 6.9.
What?
You got 6.9. Actually, 6.9 would have been my estimate, but I didn't want to show off. Okay.
Well, I took 5
Yeah, well,
to
not.
the parentheses,
5?
Oh, I didn't put parentheses.
I didn't either.
to the 2 divided by 3.
Uh-huh.
Okay.
Add 4 to that.
Anyhow, we can worry about that aspect of it, but that's something that you would approximate to an appropriate number of significant figures on your calculator if you wanted the number. Okay, if you wanted to see just where that number is on the x-axis, for example, you would have to approximate it. Okay?